Okay, let's continue our class. Today let's say the schedule. Okay, in the second week, okay, we introduce what is table-based data and data analysis process, and we introduce what is a model, and what is a very basic model named linear regression, and we discussed some idea of finding how to find the minimum value of MSE, okay, mean squared error, by using gradient descent. So currently, that is the T04. I will revisit some concept of T04 before we start our course today. And this week, okay, the third week, we will learn the next basic algorithm, which is logistic regression. And before we continue our next algorithm, I would like to introduce T05, which is visualize the machine learning tool. We have a free, open source visualize machine learning tool called Orange. Okay, it is a Python-based machine learning tool, which is I think it's very easy to use, and it provides a lot of advanced algorithms. Okay, so I think it is quite suitable for students in a business school to learn how to use it, so that you don't have to write your own. You don't have to write certain program, okay, certain basic program, because you can simply just click some items and to connect those items and try to formulate your machine learning process. Okay, so let's go back to T04. Okay, we have some okay, let's go back to 04. Okay, before we continue next topic, okay, I'd like to revisit some important concept. Okay, so basically I can write it right here. So basically, when we talk about model, okay, we're talking about we like to have a model, okay, to represent our data. For example, we have a bunch of data right here, right? Okay, and as we mentioned before, we have a lot of features. For example, if we have n features, okay, and we use a big X, okay, to represent all those features. You use those features to describe a data set, okay, and we have a target Y right here, okay. The model, okay, the model means what if I use a big X to describe the relationship between your features and the target. Okay, we mentioned before the target Y. Okay, it has several different types. Okay, it could be a numeric type, which means it is a number. Okay, like your salary, your height, your weight, and some numeric things. Okay, the other one is category. Okay, category means right or wrong, yes or no, 1 or 0, black or white. Okay, there are some applications, okay, in your problem. The relationship between X and Y, or big X and Y. The Y is the category data. Category data. Okay, so basically when we talk about linear regression, okay, when we use the word linear regression, it means the Y is a numeric data. Okay, it's a numeric data. Okay, so first one is linear regression. Linear regression assumes that the relation between big X and Y is predefined. Okay, the form looks like Y equals AX plus B If you have only one variable, x1, okay, then you write it down. However, the general form looks like this: y equals ax1, bx2, cx3, so on and so forth until certain value. Okay. However, okay, when we do the math, okay, usually we write it in this way. Okay, the variable becomes theta. Okay, so we have a theta 0 plus theta 1 x1, okay, theta 2 x2, and so on and so forth. However, usually we write it in this way: theta plus a big theta and xx. Okay, it's just a different notation, but the meaning behind those notations is the same. Okay, or sometimes we use another way to represent such kind of relationship. Okay, we have a function. Okay, we have a function. Okay, this function. Okay, the input is x, and we have to describe this function, right? So it has certain parameters. The parameters are theta. So we write the theta right here, just like this, which is the same. Okay, all the above things is the same. Okay. Okay. Sometimes we write a hat right here, which means, okay, the y hat means it is an estimation of y by using the function f. Okay, the input data is big X, and your parameters are theta, and there's a function. Okay, you can use big X to estimate the value of y, and the value the value we use right here is y hat. So the model, sometimes the model has some the model is not accurate enough. So the y hat, we wish the y hat is close to y, to the actual value, but however sometimes it's they're not close. Okay, so we have to define certain method, certain function to help us to evaluate the model. Right? So as we mentioned before, we use the value MSE, right, to estimate how good the model is. So the definition is like this. Okay, sigma. Okay, we add all the difference between y and y hat, okay, by using the square. So that's called MSE. Mean means we divided by n. SE means the error, square error. The square is right here, right? The error means the difference between y hat and y. Okay, so of course you can write it in this way. Okay. Or you can write it in this way, which is fine. Which is, oh, that really doesn't matter. Okay, in which you write it. Okay, okay, let's take a look at this one. Okay, this one, sigma. Okay, if you simply just square this item, okay, you can see that this value, okay, it is a polynomial. It's a polynomial of x, right? And it is order of 2, So basically, it is a shape like this. Okay, a curve, concave, 就是凸的哈，凸的。It's a curve. Okay, it has a minimum value. So that means, okay, there should be some the MSE value as minimum value, 最小值. Okay, of course, it happens, okay, when or where the minimum value occurs. 就是什么时候会有最小值呢 ？Okay, it depends on the value of A and B, which is the parameters. Okay, you choose different parameters, which is A and B. Okay, you get different value of MSE. However, there should be A star and B star, the optimized value, okay, which can makes the MS value to be the minimum value, right? So in that time, we find the optimized parameter of this linear regression. So the A star and B star is the optimized value. Okay, so usually we believe this A star and B star is optimized value is the best, okay, linear regression line for this data set. Okay, for this data set, because we use this data set X, okay, in this equation, okay, in this equation, okay. That's all. I think that is the basic model, okay, the basic concept of model or and the loss function, okay. When the MAC, okay, this function is called loss function. Usually we minimize the loss function to get the best, okay, model of your data. So what is next? Feature engineering. Okay, when we collect those data, okay, we have a lot of features x1, x2, xn. Okay, however, usually we have something need to do before we analyze those data, which is called normalization, which is right here. Normalization， 中文叫正规化，正规化。Normalization. What normalization means? Okay, we have different approach to perform normalization. Okay, I provide two right here. The first one is min-max scaling, which means you don't use the original xi when you analyze your data. You transform this data to another x. Why do we need to do that? Because different features right here, okay, they have different meanings. For example, weights, heights, your salary, okay, the distance between the distance you travel from your home to school, something like that. They have different scale. For example, your weight may be between 40 kilogram to maybe 100 kilogram. So it is a value, okay, most of the value between 40 to 100. For example, weight. Okay, for example, weight. Okay, you have a range 40 to 100. But how about your height? Maybe 120 centimeter to 200. How about the distance? Okay, maybe 1 kilometer to 500 kilometers. Okay, we have different values in our data, so they have different scales. Right. So I'd like to show you. Okay, let me show you this thing. If you Google data normalization, okay, and you click the picture, okay, you may find these things right here. Sorry about that. You may find these things. As we mentioned before, when we analyze our data, okay, we use loss function, MSE function, to evaluate our model, right? And we try to find the minimum value of the MSE value, right? So we do partial differentiation to find the loss value. Okay, the left hand side, okay, it is a data set. Okay, if you do not do any normalization, okay, when you find the minimum point, the minimum value of your loss function, it may look like this, okay, because the scale of your data, the curve, okay, the curve may look like this, okay, a little unbalanced in different axes， 在不同的轴啊，资料会看起来有点不太平衡，好吗？ But when you do the normalization, okay, when you try to find the minimum value of MSE, when you do the partial differentiation, okay, and your curve, okay, will be look like the right hand side, 就像右边这个图。So when you do the gradient descent to find the best value of A star and B star, which is your best parameter, okay, it is much easier. You take less step, 就是你会花比较少的步骤 to find such kind of minimum value of MSE. Okay, theoretically it looks it's like this. So we will talk about later. Okay, we will talk about in later when we talk about gradient descent. But you have to remember this. It will be much better when you do such kind of modeling. Before you do that, okay, make sure you do normalization on your data. Okay, so one of the way is to the min-max scaling. Okay, here's the original X you use. Right, you simply abstract the minimum value and you divide it by your range, which is defined by your max value and your minimum value in your feature. Okay, so you get a normalized X. I believe you familiar with such kind of scaling when you learn some statistic concept. 我想这个你们统计学的时候这些概念都已经教过了哈。The other one is Z-score. Okay. The value you subtract it from your mean value and divided by your standard deviation value. Okay, and you get the Z-score. Okay. I believe you learned it in when you learn normal distribution. Okay, so that is a Z-score. You can do either of it to normalize your data, which is good enough. Okay, which is good enough. So then the value when you find this, I think it's right here. When you find the minimum value of the MSE, which is much better, which is easier for the gradient descent to find at this point. Okay. So that's it. Okay, we have talked about this before. Okay. And that is the gradient descent, right? And that is the MSE value. Okay, for example, if we have two parameters right here, one is A, one is B. Okay, as we mentioned before, usually we don't know how to find the optimized value, right? A star, B star. Usually we don't know. So one of the best strategy is to randomly select one value. Okay, which is A0, B0, right? So we do partial differentiation. It tells, okay, goes this way. Okay, the other one is, okay, go this way. Okay, so basically it goes to this way for the next step. Okay, so it's right here. That's A1, B1, B1. And at the purple point, okay, you do partial differentiation again. You find the base direction toward the minimum point, and you so on and so forth, and finally we're very, very close to the A star and B star. Okay, so that is the gradient descent. Okay, we have talked about this figure before. Okay, so before we enter this next slide, okay, I'd like to talk about a little about the pandas. It is a Python package, okay? And usually we use this package because it's very easy to understand. You can manipulate your data, okay? As we mentioned before, the data, all of the data, okay, in our class, okay, most of them looks like a table, right? Looks like a table. So what is the basic? It's right here. What is the basic things of a table? Okay, if you have only one column, okay, x1. Okay, for example, you have a lot of data right here. If your data has only one column, okay, you can use a data structure to store such kind of one column data, which is called series. Okay, it is a data structure. Okay, we will not go over everything about pandas series data structure. So, but make sure you have to make sure you read some document, or you go to the website. You go to Google, and you find some example of how to manipulate pandas series data structure. Okay, here's an example. You have the data, okay, looks like this. So basically, this. That is the index, and that is the value. Okay. The index is Ohio, Texas, Oregon, Utah, and value is right at the right hand side. Okay, you can describe your data by using pandas series data structure. Okay. Sometimes, okay, you might have a missing value. Okay, so that is missing value. Usually, when we analyze data in pandas or by using Python, okay, NaN means not a value, not a number, which means nothing right there. So it is a missing value. Okay, we will talk about how to deal with missing value in the later class. Okay, or okay, that is the index, that is the value, and as we can see that those values are binary value, true or false, yes or no, 1 or 0, which is okay, whatever you want. Okay. The other important data structure is data frame. And data frame is a table basically. So sometimes it looks like this, okay? Right here. Right, that is the index. That's what we call x1, x2, x3, right? And we have 5 data right here, okay? And each data has different x, big X, to describe its value. So something like that. Okay. Make sure always skip all of the other things. Okay, because it's just take some time to take a look at those things to make sure you have some basic skill to deal with to manipulate the data in the data frame or in the series. Okay. So that's it. That's it. Okay. That is homework. Okay, you have to read those things and make sure you understand how to manipulate this data. Okay. All right. Okay, let's go to our next slide. Okay, which is another algorithm. It's very important as well. Okay, it's very similar to linear regression. However, there are certain assumptions which is very different. So you don't want to miss those things. Okay. Linear regression, and this one is called logistic regression. Okay, basically they are all describe the relationship between your input data to a specific column, your target. Okay. However, the difference is right here. Y is numeric. But in logistic regression, okay, Y is categorical. This is what, which means Y is one or zero, yes or no, black or white, or even a lot of different classes. For simplicity, we use binary classification right here, okay, as our example, okay. Let's take a look at this problem, okay, this one. Okay. In linear regression, okay, in linear regression, we like to try to find the relationship between x and y, so we plot it right here, so we can find the best linear regression line, like this, right? That's called linear regression. However, there are some other data, okay? Right here, okay, the x value is score. This value is what we is called NFL value, okay? The y value right here is the probability of win, which means I can collect a lot of data from NFL games, right? So it's right, something like, where is it? Right here. Line number 5 and number 6. Okay, so there's a game. Okay, one of the team get 3 points. However, this team loses this game, so that's 0. The other game score 11 points and still lose. 12 point lose, 13 point lose, and so on and so forth until this one. This one, okay, in one game, okay, it scored 21 points and win again, 25 points, win again. However, sometimes even if you get higher points, for example 26, however, your opponent get even more points, so you lose again. So it's like this, okay, 27 win, 28 wins, okay. Theoretically, the more points you get in a game, the more chance, which means possibility, okay, probability, you can win again. So basically, you have a table like this, okay. That is the game index, right? 1, 2, 3, okay. The x is the score, C over P, okay. Y, okay. It's 3, 11, 12, 13, 26, 27. Okay, the Y means you win or you lose again. So you lose, lose, lose. Until this one, you win again. Okay, you win again, and you win, so on and so forth, so on and so forth. So basically, Y, in this example, Y is a binary value. Right? It's either 1 or 0. Okay? It is not a numeric data. 就是它不是小数点，它不是小数点。It is a class. Okay, class 0 and class 1. Okay? But how do we do such kind of modeling? Okay? If you view this as a table and there's some numbers in this table, okay? And you say, okay, I have learned linear regression, so I would like to use linear regression to model such kind of data, and that is the result of linear regression. You will find the, okay, we call it best line. You will find this best origin line, okay, across this data, okay, that is x, that is y, and this line best fit those game data, right? However, have you ever think about is it appropriate to describe the data, the game data, by using linear regression? Actually, the answer is no. Why? Why the answer is no? Okay, first things. Okay, the first thing is right. The first thing is right here. Because we create a line, right? So what is this point means? Right here. That means if you score, for example, 5 points right here, your winning probability would be some, for example, minus 0.1. However, as we know, the probability, the range of probability is between 0 and 1.0. There's nothing, something called, okay, we have a probability 0 minus 0.1. We don't have such kind of things. So the line lower than 0 is meaningless. Okay, and the other thing is right here. The probability which is higher than 1.0 is meaningless. So it seems like it's not that appropriate to describe such kind of data using linear regression, right? It's a problem right here. The other one is, it's like we simply just plot those game data, okay, using the blue point right here, and you can see that this orange line does not quite fit this dot, right? So if I'm trying to draw a line, the line might look like this, okay? If I get higher point, okay, my winning possibility will be high, okay? If I get a very low score, okay, it will be very low to win. We have a very less chance to win. However, in this range, okay, the probability of winning this game, okay, decrease because I have less point, okay, and to a certain point, okay, certain turning point, okay, which I don't know, it seems like the winning chance, okay, become lower and lower. So basically, I would like to find a shape like this ZZ, okay, zigzag shape. So we don't use linear regression right here, okay. However, this shape, how do we model this shape? Okay, so basically we have a shape like this, okay. From mathematics, a lot of smart mathematicians tell us, okay, we have a shape just like what you want, okay. This shape is called it has several different names, okay. One of them is called sigmoid function, or it is called log-it function. It has several different names. However, such kind of shape, which is quite useful when we describe such kind of data. Okay, the Y is a categorical data, and it's the value of Y might be considered as a probability， 就是可以 Y 轴的值哈，虽然是0跟1，但是可以被视为是好像像几率那样子的东西。Okay, so here is the slide. Okay, so how do we model, okay, this kind of data? We have to model this kind of data. Okay, what kind of data? First, the target. It looks like a binary value, so we would like to do such kind of binary classification given x big X. Okay, I would like to show what is the Y value of this data. So it's a binary classification problem. Okay, and some training data is overlapping. 就是是交叠的嘛，比如说25分有时候赢，25分有时候输嘛，对不对？所以它是交叠的哈。So what is the base curve for this minimum? And that has minimum value. Okay, let's take a look at this one. Okay, the red shape which I draw which is looks promising, right? But sometimes, okay, maybe there is another purple line which has different shape, but different different shape. However, it may look like this, right? Or sometimes, okay, you can find another pink one, okay, which is like this. Right? So basically, we don't know which one is better. So it's very similar to linear regression. We can draw a lot of line in linear regression, right? But we have a measurement, MSE value, to evaluate different different line, okay, different models in linear regression. It's almost the same right here, okay? We have different shape right here, but we don't know which one is better. So we have to find out a loss function to help us to measure which curve, the red one or purple one or the pink one, is the best, okay? Is the best curve to describe the training data, okay? So that is, okay, so we will tell you what is the base curve, okay? We cannot use a line to fit this data, okay? Rather, we like to use a curve to model the relationship between score and the probability of a win, okay? So, given a score, okay, for example, the score, the symbol is a Z, okay? The higher the score, the more likely success occurs. So, we think about one thing, which is probability, right? How possible an event, okay? So, we define right here, Y is a random variable, 这个随机变数哈。It means success. Y equals 1 means success. Okay, we have a random variable. Okay, so usually you write it in this way. Okay, probability of Y equals 1 equals to 0.75, which means you have 75% of probability to win this game. Okay, so on the other hand, because Y is a binary variable, so Y equals 0, it is 0.25. Okay. However, when we use probability to describe such kind of things, there's no score. Right. The score is Z, right? We don't describe score in this formula, right? So sometimes it will be more like that. I would like to have a probability. Okay. I would like to predict when the possibility of win under certain condition. For example, the big Z value equals to, for example, 20 points. That is the equation which more fit to our data. Okay, more fit to our data. Okay, that is we don't directly use probability. Okay, I'd like to introduce another concept which means odds. 这个中文的 odds 翻译成应该是赔率吧，哈，虽然它不是很，这个翻译不是很好哈，但是它是就是中文是翻译成赔率的意思。The definition is the odds of success. Okay, the means P. The definition is right here. Okay, so for example, it is 3. 就是中文有时候是翻译成赔率嘛，但实际上它的意思是胜率的意思，因为它那个分子是 Py 等于1嘛，就是赢的嘛，下面是 Py 等于0是输的嘛，所以是赢的除上输的那个比率，所以是3倍啊。但是我们中文有时候因为你去运彩买东西的时候，它的翻译是赔率，但实际上它的意思是胜比上败的倍数。好，这个记得哈，这个中文有点怪哈。So it is 3 times more likely that I will win than lose. So that's the definition of odds. Okay, the higher the odds, the more likely success will occur. Okay, so it is a little bit different from the probability Py equals 1. Okay, the odds means 3 times I can win, then lose. Okay, so if we define these things, okay, the probability of win p small p 就是 py equals 1, then the odds is p divided by 1 minus p. 这个没有问题，这个就是数学。So see the figure. So how about if we draw this figure? Okay, it looks like this one. That is the p. That is the odds. Okay. So that is that's look quite weird, right? The more chance you win, okay, the more odds you get. However, the curve is too sharp, 就是它太陡了哈。So sometimes we use another function called log it. So that we can so it becomes this one. 就是你对这个function odds 这个数字学 log， 它会看起来比较平滑一点啊，比较平滑一点。Okay, so the definition of log it is like this. Okay, we simply just log it. Okay, log the odds value. Okay, this shape looks much better. Okay, however, the shape we like to use is like this one, right? Like this one. So simply just reverse it. Okay, reverse x and y, so we get this value. So of course that is because mathematicians are so smart, so they know, okay, we have a shape like this. Okay, this shape can be derived by using odds. If you have a winning probability and you can calculate the odds and you log it the odds and you reverse this shape, you can get the z shape you like to use, right? So mathematicians is so smart, they tell us, okay, that function might be useful to approach your x and y. Okay, there are some explanation right here. So if you are interested in how those shapes are created, okay, you can simply just read these mathematic things. Okay, so the next thing is that even if we know, okay, this shape looks like this, and this shape, the final equation looks like this. Equation f, the function f. Okay, we have value z, right? It looks like 1 plus e minus x. Okay, that is this. So that is minus z. So that is z, and that is fz. Oh, okay. Even if we have such kind of shape which can appropriately describe our data, but the next problem is there are different slope of those data, right? The green one, blue one, and the orange one, which is a little bit different. So how do we describe such different kind of shape? Okay, so the important thing is right here. Usually, okay, we write this z in another form. Okay, we use linear and we think about linear regression. So it's like ax plus b. So we create two additional variables in logistic regression, which looks like linear regression, which is a and b. Okay, the value of a and b, okay, which is right here. I use w right here, so maybe it's like w. Sorry. W 0x plus b, okay, which is the same. Okay, So if W0 is -1, okay, which is like this one, W0 is -1, okay? W0 is 2, which is right here. W0 is 2, and this W0 3. So by adjusting the value of A and B, which is W0 and B, okay, you can fine-tune this shape. So it's very close to linear regression, right? You change the value of A. A in linear regression is the slope. A 就是斜率嘛。B is the interception in linear regression. B 就是截距嘛。Okay? So in logistic regression, okay, the value of A change the shape, how it quickly, okay, from how quick it goes from 1 to 0, 就是 A 的值啊，它会控制你这个从1到0这个掉下来的这个速度。OK， B is a turning point， 就是 B 就会you adjust the value of B，OK，you change the turning point of this slope， 就是 B 也会B 跟 A 啊，他们会一起决定这个调的速度，还有转就是 turning point 的这个速度，不是速度的位置。Which one is best? So it's the same. In this stage, okay, we need a loss function to help us to measure which line is better than the other one. Okay, we stop right here. We come back in 10 minutes and we'll talk about how to measure the different which one we use a loss function to measure which model is the best. Okay, let's stop here.